Morning dear student friends. In this class, we are going to discuss aliphatic nucleophilic substitution reactions. What is an aliphatic substitution reaction? What in particular? Nucleophilic aliphatic substitution reaction. What are the different types of aliphatic nucleophilic substitution reactions are there? Its mechanism, everything we will discuss. It's a time-consuming subject. We'll try to discuss slowly what is an aliphatic nucleophilic substitution reaction. What we know so far is we have discussed a topic on aromatic electrophilic substitution reaction. The electrophile is getting substituted into an aromatic system. As a result, we get substituted product. Comes under aromatic electrophilic substitution reaction. Now the topic is aliphatic nucleophilic substitution reaction. Subject is different. Aliphatic nucleophilic substitution reactions. Aliphatic nucleophilic substitution reaction. Say for example, general example for your aliphatic compound, where R is an alkyl group. This is alkyl halide. Reacts with Y minus. Let us assume Y minus is your nucleophile in this case. We know that electrophile is an attacking, both electrophile and nucleophile are an attacking agent, attacking species. If the attacking agent carries minus charge, that is your nucleophile. On the other hand, if opposite is there, that is positive charged species is there, that will be called as your electrophile. In this case, the nucleophile substitutes into an alkyl, that is aliphatic compound. The aliphatic compound taken is Rx, where R is an alkyl. As a result, you will get Ry plus X minus. This is your substituted product. Nucleophile substituted aliphatic reaction. Finally, the product is nucleophile substituted into an alkyl system, aliphatic system. Therefore, this is your aliphatic nucleophilic substitution reaction, where X is called leaving group and Y is called incoming group or attacking group, or simply in this case this is your nucleophile. This is nucleophile, this is leaving group. When the attacking group or the entering group are simply the nucleophile, remember when it attacks the thing, simultaneous removal of leaving group takes place, gives you X minus as finally the product. X minus is one product and the main product is substituted product, that is your Ry. Usually Y minus, that is the nucleophile, sometimes carry minus. It is not necessary that Y, that is the nucleophile, should carry minus charge. Sometimes Y may not carry any charge. This may be negatively charged or this may be neutral. This may be neutral. Similarly, Y may be neutral or negatively charged. Similarly, the Rx may be neutral or positively charged. Rx may be neutral or positively charged. There are 4 possibilities are there. This particular compound may be neutral are positively charged. Positively charged, and your nucleophile, the Y minus, may sometimes minus charge or sometimes neutral charge. So here we have two possibilities. Sometimes minus, carry minus charge, sometimes neutral, and Rx sometimes neutral or sometimes positively charged. Considering these things, we have four different options. We have four different reactions are possible with respect to aliphatic nucleophilic substitution reaction. Remember, we are going to substitute the nucleophile into an aliphatic system. Example taken is Rx, where X is leaving group, because this is the one that is going to leave the moment the incoming group, that is a nucleophile, attacks your substrate. This is your substrate. In the substrate, there is R connected with your X, that is your leaving group. Y is your nucleophile or entering group. The product finally R1 plus X minus. There are four options. Y may be the incoming group, may be the attacking group, may be negatively charged or neutral species. Similarly, the substrate may be neutral charged or positively charged, so that we have four different reactions. Let us consider all these four reactions. Based on these things, we have now four different types of possibilities. Number 1, that is type 1, Ri plus OX minus. Type 1, RiOH minus gives you ROH plus I minus. This is option number 1, that is type number 1. Here the substrate is neutral. Entering group, that is the nucleophile. Here the entering group carries minus charge. When these two combination is there, the product is ROH plus I minus, because this is the leaving group in option number 1, that is type number 1. Now come to type number 2. In type number 2, we have Ri plus NME3. So this is this symbol. This is neutral and this also neutral. This is neutral, this also neutral. Substrate is neutral, attacking species also neutral. So that the product is Rn plus Me3 plus I minus This is type number 2. Now come to the third one, type 3. In type 3, we have Me3 plus OH minus, and the product now here is NME3 plus ROH and NME3. In type 3, substrate is positively charged. Attacking species carries negative charge. The product is ROH, NME3. Now come to last type, that is type 4. In type 4, we have NME3 plus H2S gives you RSH2 plus NME3. There are 4 options. There are 4 different types based on whether the attacking species carries negative charge or neutral one, and substrate is neutral or positively charged. Type 1, substrate is neutral, attacking species is negatively charged. The product is that one. Type 2, substrate is neutral, attacking species also neutral. The product as a result that one. Type 3, substrate is positively charged, attacking species carries minus charge. The product will be that one. In type 4, substrate is positively charged and attacking species is neutral, and ultimately that will be our product. So these are the 4 different types we have based on the nature of your attacking species as well as on the nature of your substrate. See the board, try to understand all the different types of aliphatic nucleophilic substitution reactions. As far as now we are moving a little bit ahead of this in this subject. As far as aliphatic nucleophilic substitution reactions are concerned, we have number of reactions. One is SN2 reaction. SN2 reaction, that is substitution nucleophilic bimolecular reaction. Another one is SN1 reaction, substitution nucleophilic unimolecular reaction. And the last and one more we have, that is substitution nucleophilic internal mechanism. We have 3 different types of important aliphatic nucleophilic substitution reactions are there. One is SN2, another one is SN1, another one is SNI. We will try to have the discussion on one by one slowly. Number 1, different types of aliphatic substitution, nucleophilic substitution reactions are concerned. We have SN1, this is 1. Abbreviation of SN1 is substitution nucleophilic unimolecular reaction. Where 1 stands for unimolecular, N stands for nucleophilic, S for substitution. Substitution nucleophilic unimolecular reaction, SN2. Substitution nucleophilic bimolecular reaction. And we have SNI, where I stands for internal within the molecule. So we have substitution nucleophilic unimolecular, substitution nucleophilic bimolecular, 2 stands for bimolecular, substitution nucleophilic internal reactions are there. I stands for internal. We have 3 different types of aliphatic nucleophilic substitution reactions are there. These 3 reactions we will try to discuss one by one. Yes, now it is clear. I hope all you have in your mind the clear-cut idea on what is aliphatic nucleophilic substitution reactions are. What are the different types of aliphatic nucleophilic substitution reactions are there based on the nature of your attacking species and based on your substrate. And finally, what are the different important aliphatic nucleophilic substitution reactions? We have one is SN2, another one is SN2, and one more important aliphatic nucleophilic substitution is concerned. We have SNI, that is substitution nucleophilic internal. And now we are going to enter a new thing, that is what is SN2 reaction. Behind you know that under SN2, then under SN1, finally under SNI, we will try to discuss what is what in a simple manner, starting from the reactions concerned, then the mechanism concerned, kinetics evidence concerned, the proof if we have further that concerned, everything we will try to discuss. And we don't want to continue the new topic, that is SN2, in this class, because it's a little bit time consuming. We'll try to discuss all these three important reactions, aliphatic nucleophilic substitution reactions, that is SN2, SN1 and SNI, in the next session. Till then, bye.